Hello everyone, myself Akash, pursuing my BE at Sri Venkateswara College of Engineering, Department of Electronics and Communication Engineering. Today I'll be discussing about the topic data flow diagram of ARM processor. Introduction to data flow diagram of ARM processor. A data flow diagram illustrates how data moves within the ARM processor. It showcases the flow of data between various components within the processor. Understanding the data flow diagram is crucial for comprehending the functioning of the ARM processor. In the data flow diagram, we have the data which is sent to the instruction decoder and then it is sent to the sign extent where the register file loads the registers from R0 to R15. It also sends it to ALU, parallel shift, MAC, and then in the return process, it is sent the, to the RD result. The components of ARM processor. The ARM processor consists of components like ALU, registers, control unit, and memory. These components work together to execute instructions and process data. Each component plays a vital role in the overall functionality of the processor. WAC, NVAC, ARM core, ETM, DAP, memory protection unit, serial wire viewer, flash patch, data watch points, code interface, SRAM are the components of an ARM processor. Data flow within the ARM processor. Data flow starts with the instruction fetch phase where instructions are fetched from the memory. The data then moves to the decode phase where the instruction is decoded to determine the operation. Subsequently, the data is processed in the execute phase where the actual operation takes place. Example of data flow in ARM processor addition operation. Let's consider an addition operation. Add R1, R2, R3. In the fetch phase, the processor fetches the add instruction from memory. During the decode phase, the processor decodes the instruction as an addition operation. In the execute phase, the processor adds the contents of registers R2 and R3. The result is stored in the register R1. This showcases the data flow during an addition operation in the ARM processor. Data movement in the ARM processor. Data movement within the ARM processor occurs through registers and buses. Registers temporarily hold data during processing. Buses facilitate the movement of data between different components of the processor. Control signs in ARM processor. Control signs coordinate the flow of data within the processor. These signals regulate the timing and sequencing of the operations. Control signals ensure that data moves efficiently to the processor. Interrupt handling in ARM processor. Interrupts are the signals that temporarily halt the processor's current operation. When an interrupt occurs, the processor saves its current state and handles the interrupt. Once the interrupt is processed, the processor resumes its normal operation. Best example for interrupt handling is ourself. How we handle our situation in different real lives is the best example for interrupt handling. Data flow diagram visualization. The visual representation of the data flow diagram can help understand the flow of data in the ARM processor. It shows how data moves from one component to another during instruction execution. Visualizing the data flow diagram enhances comprehension of the processor's operation. Conclusion. The data flow diagram of the ARM processor illustrates the movement of data within the processor. Understanding the data flow is the essential grasping of the functioning of the ARM processor. By analyzing the data flow diagram, one can appreciate the intricate process of data processing in the ARM architecture. I hope this little information was useful to you. Thank you.